Hello everybody. I am going to start this here. Here's an assignment that will be on Google Classroom. So if you see here, this is called Alien Genetics, Genotype, Phenotype, and Offspring. Okay, so I'm going to show you how this is done and then you can do it at home. So here's how it works. The first sheet has all of the traits that you're going to find out what your monster has. Okay, the parents of the monster. We're going to figure that out. And we're going to use a coin to do it because we're going to get random results. And if you get a heads, it's going to end up being a dominant gene of one of those. And if it's tails, it's going to be a recessive gene of one of those. Okay? And I'll show you how this works. So on this worksheet here, I already did 2 traits for the mother. As you can see right here, I found out her 2 alleles. One was from her father, one was from her mother, and this was for the head size. This is for the head shape. She had recessive both from the father and the mother, and so I'm going to show you how that works. So right here we have the head size, large head or small head. Large head is dominant, small head is recessive. So when I did it, I ended up getting 2 large head alleles. She got one from her father, one from her mother. That's what we're trying to find out. Then I did the round head right here, and they both came up when I flipped the coin. When you flip the coin and you get heads, that means that one allele of the trait will be dominant. If you flip the coin and it ends up to be tails, it will be recessive that you write down. And that tells this paragraph tells you about that. So I'm just going to go through a few examples to help you, to show you, okay? So here, we're going to do horns now. So does it have horns or no horns? So we're going to flip to see if this mother received alleles for horns from father and what she received from the mother. So we're going to flip, and it ends up to be heads. So for horns, the letter is G, and it's dominant because I flipped the heads. So I'm going to put a capital G there, okay? She received that from her father. Okay, now we have to find out what she received from her mother. So we're going to do the horns again, and we're going to flip it, and it gets to be heads. So 2 capital G's, that means mother does have horns, okay? Then we got arms. So we're going to do arms, and arms for me, and A is capital for dominant, so it'll be a capital A. So I'm going to flip this over, and we got tails. So it's going to be a little a for arms, okay? And we're going to do it once again for the arms, and we got heads. So we're going to put a capital A. So you just do that for the mother, and you do that for the father, and you continue down till you get 2 of them for each one. The reason I'm doing 2 of them is because the parent, this parent that we're trying to figure out in order to go on for some offspring over here, we need to find out what their parents gave them, right, for the trait. And each one gives them 1 allele. So you just continue doing that for the mother. You do the same thing for the father, okay? Then you write the genotype. Well, you really just repeat this to show that the genotype is this, okay? Little a, big A. The phenotype is what you can see. The phenotype is what you can see. So in other words, for the head size, if they had 2 dominant alleles and dominant is large, we will write large head right here for the phenotype. Large head. That's what we can actually see with our eyes is the phenotype, or the physical appearance. Then we have head shape. We have recessive 2 little r's, which is oval head. Because they both, if this was a capital R and a little r, it would end up being a round head. But because both of them are recessive, they have oval. So we're going to put oval head. Here we have the horns. Here we have two capital G's. So what is that? Is that dominant or recessive? Dominant, you're right. So dominant. So dominant is having black horns. So we're going to put black horns. And the last one here that I have an example of is arms. We have small a and a large A, but even if you have one dominant A from one of her parents, right, it's going to be whatever the dominant is. And the dominant is 4 arms. So we are going to put 4 arms here. Okay, so you do that all the way down here with the other traits. Right here, legs, fur, so on, right? And then you do the father the same as you did the mother. So all of these are going to be filled out, right? Then you're going to move over to the kids. And here, with this, what you're going to do is you're going to take the mother's alleles for each one. So here's genotype for the mother is capital H, capital H. You're going to put them over here on the left side of the Punnett square, right? And we're going to do the father's head right now, just for the example part, okay? So the father is, we got tails, so we're going to put a small h. And we're going to do another one there, just to show you what we're doing. And that's a capital H. So he has a large head as well, right? Because all needs to happen is to have one dominant allele to make that be dominant or the phenotype. So here we're going to put H, capital H and little h, okay? Watch. And you can put it right here and little h, like so. Now we're going to find out what the children are. So when we find out what the children are, we're going to put capital H, capital H, capital H, little h, follow, capital H, capital H, capital H, little h. So here's what the kids ended up being. And they are all dominant. They have at least one dominant allele in each. That means that all the children, if these two have children, they're all going to have large heads. So we're trying to figure out for this particular offspring, and that's going to be the percentage is 100%. Small head, 0. The offspring will be a large head. Okay, that's what I'm going to write down. So we got 100%, we have 0, and then we have large head. So that's how you do it. All right, if you have any questions, let me know. Thanks. Thanks for playing Geno Monster.
You got this.
You got this. All right, that was Stan, if you don't know. Okay, and here we go.